Hi and welcome back. This is part 2 of a series of videos where we're going to look at the contents of a $40 box of Commodore computers that I got at the Portland Retro Gaming Expo. And we looked at one last time, and if you haven't seen that video, be sure to go back and watch it. That kind of has my testing methodology, which is probably just a bit unorthodox, so you might want to go back and see that. And you can also find out how that first Commodore 128 we looked at fared in the scheme of things. Now we're on to the second one, and there's actually 3 of these that were part of that box of computers, along with a Commodore Plus 4. And this is going to be our Commodore 128 number 2. And today we're just going to kind of go through it, see if it works, or what works and what doesn't work. And I'm hoping for as good of results as we got in the last one. The last one fared pretty well overall in the scheme of things. And this one we're going to go ahead and boot up and see what happens. And you notice we do have a data set connected up to it, and I've got my video out to a composite to HDMI scan converter, so I am able to capture some of this, although I don't promise that the quality is going to be the absolute best. It's not a very high-end device. All right, let's go ahead and power this Commodore 128 up and see what happens. Okay, this is a pretty good sign. We've got video out of the Commodore 128 mode. It's booted into the ready prompt, and that's good news. So one of the things that we're going to want to do, if you watched the last video, kind of one of the things I do is just type in just the really quick and basic Hello World program. Oops. Okay, we've got a problem already. So the keyboard is not functioning correctly. And I'm just going to quickly kind of go down the key rows. And it looks to me like at least the middle row's got problems. All right. Number pad's good. So this middle row of keys, it looks to be what's at issue. So starting with A, we have no A, S, no D. Okay, I'm seeing a pattern here. So it looks like we have every other key on this key row, with the exception of the return key, is not working. So that tells me it could be a couple of things. You know, of course, it could be the I/O chip in here. It could be the cabling to the keyboard. It could be the keyboard itself. There's a membrane in these that can have issues like that. So just to eliminate a lot of complicated troubleshooting, I think what I'm going to do is to take a known good keyboard, put on this system, and if that works okay, we know where the problem isn't. So that will just narrow us down to the keyboard. Then we can troubleshoot and look at the keyboard and figure out what's wrong. So right now I'm going to just go ahead and shut this off, and we're going to quickly exchange keyboards. I can tell this unit's been apart before, because we have a couple of non-original screws and then only one screw in the front. So this one, this is not its first time being opened. Okay, when I open these up, I always got to remember to grab the LED connector there before I open it any further. And then we have our keyboard connector. and everything basically looks good there. I don't see any loose wires or anything hanging off, though if the other keyboard works, we're going to have to check into this a lot more closely. All right, the last thing to do to remove this is to pull out the little ground screw there, and interestingly, that is not the right kind of screw there. So not just the case screws are wrong on this one. This has got some interesting stuff in it. We have a, looks like kind of a stripped out Torx bit here. And we'll go ahead and get that out. Or excuse me, a Torx head screw. So we need our Torx bit. All right, we'll remove that. And now, for just a little bit, this keyboard is going to say number 1 on it rather than 2, but no worries. That's just because, of course, we are borrowing it. So we're borrowing it off the other Commodore 128, and we know that this keyboard is good. So we'll strap that down, and I'll go ahead and hook up the LEDs. And just really quick, we'll do another test. And here we go. All right, let's go ahead and try that middle row that was the problem. And that seems to have fixed the problem. So we know that we're dealing with a keyboard issue on number 2, and I think then what we'll do is just kind of set the rest of the testing aside for the moment and start digging into that other keyboard. One thing that I know about these keyboards is that they're a bear to kind of deal with the membrane, just because of there's just 1,000 little screws here. So real quickly, I'm going to get this out of the case so we can work on it a little more easily. And even that requires removing a few screws. So the other thing is they have a bunch of soldered keys that before we can pull the back, we're going to have to unsolder those. So yet another thing. There is a red wire that's loose in the connector, but I looked kind of at the back of those when I pulled the cable off, and everything seemed to be well plugged on, so I don't think that's our issue. I don't see any breaks, any loose wires here. So other than that connector that's loose in the plug here, I don't see anything obvious there. So I can tone that out, which will be easier when I have this board flipped over. So I'm going to pull the screws out, and then I'm going to go ahead and unsolder these kind of dual state key switches there. So okay, now we got to pull off these wires off these switches, and these look like they have kind of like a little loop curled around these. Okay, I think we have all the screws out. Should be able to pull out this board, and there's no electronics on here. This is just strictly wires and and traces. So we were looking at that middle row of keys, which would be here. And we'll be looking at something that would be in common with every other key. So we'll have to take a quick look at this and see what that could be. And we can even trace everything all the way back up to here and then even to the connector. So I think that is what we're going to do. All right, I need to turn the keyboard up so I can keep track. So this is the shift lock. This is the A key. We know that A, D, G, J, L, and semicolon don't work, but are equal and return do work. So what we're looking at here is, this is A, starting from A, we go to D, G, aha! What is all of this? Right there. Big old spot of corrosion. I think that's probably our issue. Now the thing is if we've got one bad connection due to that corrosion, do we have more? I probably should not be lazy, and I should spend a little bit of time toning out these others. So this first one in looks pretty bad. Okay, we do have a connection to that pin. That's our second trace up. So we're going to go from here to pin 10, and we have a nice route to take it. We can take it just along the edge of the circuit board and straight up. Put a little bit of fresh solder there. And we're going for pin 10. I may just put a smudge of hot glue on the bottom of this just to keep it kind of out of the way. Okay, what I actually just did there is I did bodge this, but there was some interference on the keyboard, and I cut a small piece of factory kind of assembly spruing off there that we didn't really need, so that would run clean. And I changed my mind. Instead of running it on this side, I went ahead and ran across the back, and I toned out our dead row of keys, and I think everything is working great again. So I think it's now just a matter of reassembling the keyboard and soldering the connections back up, reinstalling, and then I think we're going to be good to go. So we'll find out whether or not this has fixed our keyboard problem. Part of me feels like I should not be putting this back together without cleaning it up, but I really want to just kind of get through the testing part of all of this and then clean them up. Because I may be mixing, matching parts together from the different systems so that I can create, the most ideal one for my collection. And I have not decided what's going to happen to the rest of them yet at this point, so still figuring that out. All right, before this goes completely back together again, I kind of want to check this out, make sure that it is going to work. I'm going to even screw that ground cable down. All right. Okay, here we go. Let's see if our keys work, and let's take the caps lock off. Yes, we now have that row working again. Good. And the other ones. Are working as well. Good. All right. Well, I think we can go ahead and button it back up the rest of the way and continue on with our testing. Okay, here we go again. So our keyboard is fixed and we can start going through our testing again. So first things first, we power up, jump into Commodore 128 mode. All right, a nice functional keyboard. And there's our running Commodore 128 mode. So that means our 8502 processor is working, and it means our VIC-2 chip is working. That'll pretty much be the same situation, I'm pretty certain. We jump into Commodore 64 mode. And this time I went ahead and did it just by holding the Commodore key down and rebooting the power. And there we are in C64 mode. Everything's working fine. So our first set of tests have been accomplished. Next thing we need to check, just like with the other, is we want to check our 80 column mode. And to do that, I'm going to need to plug in the special adapter that I made in the last video. And this will just be monochrome, so nothing colorful, unfortunately. And we'll go ahead and put our 80 column key in the down position and fire up the computer. And there we go. There's our 80 column monochrome mode. And just like before, I really think this monochrome, even through the converter, is so much better than the color. There we go. So what we've done there is we've tested our second video chip, our VDC. So we know that that's running. The next thing I'm going to do really quickly is I'm going to plug in our cassette tape or our data set. And I have a sound program that we used in the last video to check out how things are working as far as the SID chip goes. The program I have is a Commodore 64 program from Compute Magazine way back in the day. And we're going to use our Go 64 command this time and switch to Commodore 64 mode. And we're going to load this off a data set. So this should be fun. Hopefully I've rewound this far enough. I didn't really check the counter, so cross my fingers that I'm at least back before the program. So to load this, we're going to load. Our program is SNDB. We're loading it from Cassette, so we're going to pick a device number 1, press play on tape, and let's see what happens. So the first thing it's going to do is it's going to search for the program, but it'll find any other programs that are here before that on the tape. So good old cassette tape being a sequential device, we've got to just run through it until we find the program. And there's a different version. So it found SNDA, so it'll start searching again here in just a second for SNDB, and then it should load it after that. And I love how the Commodores go to a blank screen while they're loading from tape. Other computers will just show all kinds of gibberish on the screen, which is what you'd see on the Commodore if they didn't screen blank it as well. But I don't know, it's kind of fun to watch the gibberish go by on some other types of computers that have cassette tape. All right, our program loading is complete. So I'm just going to go ahead and shut the cassette off, even though the 128 has stopped it. And let's go ahead and do a listing and see what this thing looks like. And there's our basic program. This is a kind of a synthesizer program that allows you to manipulate the SID chip to make different sounds. Now, like I said in the last video when I used this to test, I am no expert in synthesizers, so we'll just see how this goes. So now we have some different settings we can set up here. So let's do a rising sound and pick a few options here. And we'll say yes to hear the program voice. And we'll do, let's do 100 for our frequency this time. Do our starting frequency as 1, ending as 255. And loop rate, let's do 50. And that SID is definitely doing something. Now, I personally think that this sounds like a stronger chip than the one in the last 128 we listened to. It was working, yes, and it was making sound, but this sounds way crisper than that chip did. So I'm thinking this might be a better SID chip, but I'm going to go ahead and say that we've checked the SID more or less. I realize to be sure that it's working 100%, we'd need to run it through its paces a lot more, but we are hearing audio out on it. So we'll call the SID at this point good. Now the next thing that we're going to try is I'm going to set us back up for 80 column mode, and I'm going to go ahead and use my SD Whoops, it's stuck down here. I'm going to use my SD to IEC device. So this is a little disk emulator, and we're going to unplug the data set so that we can use that to power the emulator. If I can ever get the cassette to let go. So we're going to test out the system a little further by using a boot image of CP/M that I have on my disk emulator. And this is set up to auto boot. So when I turn this on, what we should see is the 80 column mode come up. We should see it load CP/M and run CP/M. And if that actually works, then we know the Z80 processor in our Commodore 128 is also working. And by the way, on that last test where we were checking the SID chip, that also gave us a chance to check out the cassette interface too. And we know that that's working just fine. So if I have this right, we should just have to power it up and wait for it to boot. And this is a fairly lengthy boot process, unfortunately. It's not really fast. And like I mentioned in the last video, it seems to me to be a little bit of limited utility, but maybe if you had one of these back in the day, you were really happy to have CP/M so you could bring those work files home and maybe you run WordStar or something like that. Do let me know in the comments if you actually had one of these and used the CP/M mode in it. I don't know that I've ever talked to anybody that actually used it that had one of these. So, and unfortunately, because so many software vendors and game producers were interested in large markets, they never really took a lot of advantage of the 128. So I think for most people, not only did they not use the CP/M, I don't think these machines were much more than glorified Commodore 64s. That's kind of sad to say, but I think that's the truth. All the games that were out there, they were these dual platform Commodore 64 and Commodore 128, and I totally understand why they would do that because, you know, certainly it was important to them to reach the largest audience, and if they only wrote for Commodore 128, then that was going to be pretty limited. Okay, there we go. So we are at an A prompt. Do a quick directory. Well, I say quick, but not really quick. And we can see that we are in CP/M mode right now. So that tells me that our Z80 processor is working well. We see the 80 columns. We know that the second video chip, the VDC, is working well. And I think that we have our second basically fully functional Commodore 128 from our $40 box of Commodore computers. So I'm feeling pretty good about that $40. And we did have to fix the keyboard, but this seems operational. Like the other one, it's filthy. It needs cleaned up, and I'll be doing that soon. And we'll be able to see the results of that probably in the next video when we're showing off the third Commodore 128 and seeing how it operates. So that's really all that I have for today. I wanted to make this a little shorter than last time. I went over things fairly quickly, but if you want more detail about what I'm testing, how I'm testing, go ahead and go back and look at the last video where we looked at the Commodore 128 number 1. I hope you enjoyed the video today. If you did, go ahead and give it a thumbs up. And also consider subscribing to my channel where I'll be doing more of this type of content. Next time, we'll be going over more of the Commodores that came in that $40 box, so it should be interesting to see if we have any more working computers. Thanks again for watching.